hope you enjoyed lunch. Having so much choice was great. Diversity is a nice thing to have. However, if you're a developer in the Apple ecosystem, you're probably using Xcode and the Apple-provided frameworks. Someday, however, you're curious. You look up some stuff on the standard library, you find this page, and you see there is a link to the source repo. So you click on the link, and you go to GitHub. In the Swift repo, you see the source of the Swift standard library, but then you see it's from the SwiftLang organization. You go there, and you see that they have more than 60 repositories. But this is SwiftLang. You thought this would be the Apple organization, and you would be right. The migration of the Swift fundamental elements to the SwiftLang organization was announced last year in June only. So you go to the Apple organization, and you find that they have more than 340 repositories. So that's a total of more than 400 open source projects ready to be discovered. There must be some interesting things in there. So we talked about it a bit, or the panelists talked about it a bit yesterday during the talk show. AI, of course. Who is using AI to help in their day-to-day work? Okay, keep your hand up if you trust what the AI is telling you. Okay, well, I am an AI. I'm an avid inquirer. I love to discover, explore, experiment. I also love to collect old tech, but that's another story. And just like an AI, I like to crawl the internet and GitHub and find some interesting tidbits. The only thing is I do it legally. The other thing is, just like an AI, you should not trust anything I will say. So, although I will tell you about quite a few packages that I find interesting or I used in some projects, I'm not an expert in any of them, and the goal of the talk is not to go in-depth or to be a step-by-step tutorial. My goal with this talk is to give you ideas, to show you what's out there, what you can use and when you could use it, but also what you can learn from them, not only by using them, but by looking a little bit inside. And I will give you pointers if you want to go further. I'll give you a lot of pointers. But don't worry, the slides of the talk and the links to all the resources are already on my GitHub account. And Markdown, okay. And some of the sample code I will publish very soon to GitHub also. This is the QR code for the Q&A. Hopefully we'll have a bit of time to do it live, but otherwise I'll check on the Slack, and I will be around for the whole conference until tomorrow evening, and you can always contact me on LinkedIn or Mastodon. So let's start gently on the desktop with a package, well, quite a few of you might already know about. Swift, of course, we use for developing applications, but it's also a great language for scripting and command line tool. So let's imagine we want to do a small tool that would parse a Markdown file and produce a table of content. We would need to give it the file name, maybe an option with the depth of the table of content we want to produce, and a flag to skip sections that do not have any content. So the standard library has everything that you need to do that. That's the command line enum that has an arguments property that is an array of strings, including the command line itself. So it's just like the good old days in C. Of course, soon enough, you find out that your users are running the tool without providing a file name, providing multiple file names, or some users are not aware that Roman numerals are kind of not in use anymore. So you could, of course, code everything by hand, all the parsing and all the handling the hedge case, but there is a package that can make your life much easier, and that's the Swift argument parser. It can handle much more complex command line argument structure. So let's start by creating a executable using the Swift package manager, and we add the Swift argument parser as the dependency. If we look at the generated source code, we can see the @main attribute and the main static function that implements that. And we'll get to that a bit later. Now, we can take advantage of Swift argument parser by importing the module. conforming to the parsable command protocol, and then transforming our main method into a run method. But that @main is still there, and we shout out, oh no. And we don't provide a main static function. So where is it coming from? Well, if we look into the source code of parsable command, we see that it is provided there. Oh, sorry, that was a bit too fast. So it's provided there, and that's the way that parsable command or Swift argument parser becomes the entry point of our code. Now, I use Swift 6.2 here to create the executable package. If you would use Swift 6.1, the structure would be a bit different. And there are some interesting things around that @main argument. So I'm planning to write a blog post about that soon. But let's move on for now. Now that we have our base, we can add a property and decorate it with the argument property wrapper. And argument parser will take care of the rest for us. Notice that we can use any type, not just string, and we provide a transform closure so that we can convert the incoming string to the dedicated type. And with that, if we launch the tool and pass a file name, it gets properly picked up. Without providing any anything else ourselves, it will handle the case of no argument being passed or multiple arguments being passed, and it will provide error messages and some usage information out of the box. Similarly, we can introduce the depth option and provide a default value. We can also have some custom validation logic and throw validation errors that would be translated to messages to the end user. Handle the flag and add some custom information to the help that would be displayed. This runs not only on macOS, but on Linux and on Windows, the same code. Quickly, if you're running on Linux or Windows, you still define .macOS as the platform. There is no .linux or .windows or whatever in Swift Package Manager. If you want to go further with Swift Argument Parser or the command line tools, I would recommend a talk by Charles Pisota last year at Pragma, or the year before here at SwiftLeeds by Paul Piela. Paul, who tomorrow will show us how to use instruments to optimize our code. Let's now switch gears, go cross platforms, and talk about data. Let's look at protocol buffers. So protocol buffer is a language-neutral, platform-neutral, extensible mechanism for serializing structured data. It can be used for transport, such as it's used for gRPC, but also for storage. You could replace JSON with protobuf. How does it work? You first create a specification for your data structure, then use the protobuf compiler to create specific source code, and you use that along with the runtime in your application. And it's available for a wide array of platforms and languages. So let's see an example and start by defining the data structure. Let's say we want to model the information for badges at a conference. Might want to do that. This is what the protobuf spec would look like. We define badge info structure, which is called a message, and it has different fields. For each field, we need to define the type, and you have the default basic types like string, integer, etc. But you can also define enums or embed messages within one another. All fields must have a unique number. It's a unique identifier, and it's used by protobuf to match between the data that's serialized and the definition of the objects, and you can't change that or update that later. In protobuf, all the fields have default values. So it would be 0 for integers, empty for the strings, but you can also, of course, define your own custom values like we do it, default values, sorry, like we do it for additions. So now, with that, we can generate specific source code. For that, we use the Google protobuf compiler. Easiest on macOS is to use Homebrew, and then we can generate source code like we can generate Python. But we don't really care about Python. We would like to have Swift. And so if we list all the languages supported, we don't find Swift. we find Objective-C, but no Swift. And indeed, by default, the Google protobuf compiler doesn't support Swift. So that's what why we use the Swift protobuf package. And it provides both an extension to the compiler so that it can generate Swift code and the runtime that will be required later to use that code. To install it, again, Homebrew is the easiest way. And even after you install it, it still doesn't list Swift, but it is there, and you can generate the Swift code fine. Okay, let's now use it in a simple application where we'll create some batch data and persist it to a file. So we create a command line tool in Xcode, add the Swift protobuf dependency. We add the protobuf dependency, but not the plugging dependency. We don't need that on runtime. It was just for the compiler. And now we copy the file that's generated into a project. And let's take a closer look at that file. Well, we see that the generated code is not really lean. It's quite full of stuff, and it wouldn't be the way we would write it. And in fact, there are some protobuf-specific things in there. For instance, I told you that all the fields have a default value, and so it means that the properties are not optional. And we can see here that we have the default empty string, and we have the default value that we defined, the one for additions. But still, there are properties such as has email and has additions that are added, because even if there is always a default value that you would get back, protobuf still allow you to check whether a value was explicitly defined when you encoded the data. Okay, so with this in place, we can import the Swift protobuf module, create some data, convert it to a binary payload, and persist it to disk. Now remember the Python code we generated the first time I ran the compiler? Well, you can create a small Python tool that would just read the data and display it. And so here it is, data we persist from Swift that we read for Python. Now, one of the things that protobuf is very strong with is backwards and forwards compatibility. And so, in hindsight, having the email on the batch might not be a good idea, so we prefer the Mastodon handle. So we remove the email, we add the Mastodon information, but we need to make sure that we don't reuse that identifier. That would screw up the decoding, and so we need to assign it a new one. With that, we can regenerate our code, adapt to provide Mastodon information, and persist it to a new version of the file. Now, if we use the original Python tool with the new version of the file we persisted, it will run just fine. It will just not have the Mastodon information, and when we get the email, we get the default empty string. Of course, we can also regenerate the Python code, and then if we read the latest version with the latest code, we have all the information, including Mastodon. But if we use the new version with the old data, everything still works fine, and we get the default value again. So when would it be appropriate to use protocol buffer? Well, it's appropriate to serialize packets of typed structured data that are up to a few megabytes. And again, it can be used for ephemeral network traffic or long-term data storage. Where it really shines is when you are cross-platform. I used it in a project where we have a mobile device communicating with an IoT device. Here it was a battery. And we agreed on the protobuf spec with the firmware developer. Then when each our own way, it did generate C++ code that he embedded into the ESP source code. I generated iOS code for the iOS app. I also had to generate Kotlin code for Android because you need to pay the bill, but yeah, it all works together quite fine. I also have this side project, which is a e-ink-based badge, which is running embedded Swift, and I have also an iOS app that over Bluetooth would send the data that gets displayed. And I wanted to use Swift protobuf for that. Unfortunately, the runtime is full of existentials, and embedded Swift doesn't support existentials. So I had to look for something else. And this year at WWDC, there was this session that introduced the span types that is part of Swift 6.2. And they also talked about a package that is providing a specific type, a span type, to facilitate binary parsing. So the Swift binary parsing. So could this be something I can use for decoding protobuf in embedded Swift? Well, I give it a quick go, but this package is still in the early stage. It looks promising, but it has some rough edges, and so I couldn't make it work yet, but I'll keep you posted. Now, using protobuf over BLE is interesting, but typically most developers would do something like connecting an iOS app to a server over a REST API. And so there are clear similarities between the two. Just as a protobuf spec defines the data structure, in the OpenAPI, the REST world, OpenAPI is the de facto standard to define and document an API. An OpenAPI specification is a YAML or JSON document that defines that API. And so if we continue our badge example, and we would like to have an iOS app that talks to a server to retrieve like the list of badges, we can create a first iteration of that spec. We define one operation to get the badges. Now, there are different ways to work with an OpenAPI specification. You can get one document and then decide to manually implement the code, client-side or server-side, that would comply with the API. But you could also decide to implement the server-side side of things and then generate the OpenAPI documentation from there. Or maybe you want to iterate quickly over the specifications, and you can generate both the client code and the server code from the API. And if you want to do that in the Swift world, there is a Swift OpenAPI generator. So we can use that to define both or generate the code for the server, and we create a small server using Vapor. And you can then also generate the client code that you can include in an iOS app that displays all the data in a simple list. So I will now show you all the steps to get there, because one, we don't have enough time in the whole session. Two, the Swift OpenAPI generator documentation just does that, so it has a whole step-by-step tutorial, both for server and client side. And three, there is the dub.dc video OpenAPI generator that also has a tutorial kind of thing. But I will show you the results. So we have a server implemented in Vapor, and it implements the one endpoint, and here it's static data, just for demo purposes. We can run the server, and then have an iOS app that just fetches from the API and displays the result. Now, I know this is really impressive, and all conference organizers want to use it. But all the organizers told me that they are running their infrastructure using containers. And so how can we provide easily a container image for our server? Well, if you use the Vapor command to generate a project, Vapor already will generate a Docker file for you. And it's fine, it's one way to do it. But it feels a bit alien to Swift developers. It's something we don't really know about. So is there another way? Well, yeah, there is. There is the Swift container plugin. And this allows us to use a plugin to Swift Package Manager, so use that tool that we are familiar with to create the Docker image, or the container image to be more precise. So to use it, we open our server-side project, and we add the dependency on the package. We don't define a plugin in the package manifest, though, because we don't want to run it every time we do a build. What we want to do is run it ourselves when we need it. And to do so, we will need a few things. So container mostly run on Linux, and so we will need to cross-compile or use a Linux SDK. So we need to pass in the Linux SDK. And as we're building an image, we will want to push it somewhere, so we need to push it. We could push it to Docker Hub, but here we would like to use an image repository that we run locally for our tests. For the SDK, we'll use the static Linux SDK that's available on the Swift.org website. And for that, you need to use the custom toolchain, not the one that comes with Xcode. And you need to make sure that you align the toolchain and SDK version. For the registry, there are many solutions available, but Docker offers one, which is quite easy to run. So you just have to run a runtime, and it can be any container runtime, Docker, Podman, whatever, with the image. However, we can also use something from Apple. So they introduced at DubDub this year their containerization solution, and that is 2 open source projects. One is Containerization, and that is a collection of Swift code that supports containers. The other is called Container, and that is the tool to be the container runtime itself. And so that's what we can use in our example. And so after installing the tool, we can just use the same command that was in the documentation, only using container instead of Docker, and it fails. So there's a network error. Turns out that under macOS, the AirPlay receiver, which is on by default, uses the same port as in the example. So if we turn that off, everything is fine. So we can now just use Swift Package Manager and create our container image. And this gives us a reference to the image that we can use later to run the image. There is one additional bit of information that we need, and we can find it at the bottom of the original Docker file, and that is the information that gets executed when the image is run. And so with that, and with that information and the image reference we get, we can now run our container. And with the container running, we can call our API and see the results. So there are several presentations by Ewan, which is the creator of the plugin. They're all online, and they go into much more detail than what I've done here. This is the latest and the most complete one, so I would recommend that one. Now remember, I'm an avid inquirer, so I'm curious, and so I looked back at the iOS project and looked at the dependencies, and I saw something that caught my eyes. There was something called Swift numerics. So what is this? Well, I go look up the details, and Swift numerics is focused on mathematical operation and numerical computing. Well, duh, that's a bit in the name. But even if that's not your focus, there are still quite interesting things to note about this package. Well, if you look at the description, it says that the modules that from this package fall into 2 categories. One is API that is too specialized to go into the standard library. Okay. The other is API that is under active development toward possible future inclusion in the standard library. And so I find it very interesting that this package shows a bit what would come in the future standard in the platform. Now, more concretely, Swift numerics can already be helpful in a number of ways. Let's say, for instance, that you have this function that you want to make generic. However, it's using a trigonometric operation. So over what do you want to make it generic? Well, Swift numerics introduces the real protocol and makes double and floats conform to it. And so now this allows us to rewrite the function to be generic over all representation of real numbers. Also, if you're looking for specific mathematical operation, looking at Swift numerics might be useful if you don't find something in the standard library. For instance, if you were used to use these kind of things, so assert equal with an accuracy parameter when you were writing XCT test case, and you want to convert to Swift testing, well, how you convert that? There is no specific construct. Well, in Swift numerics, it provides is approximately equal function, and that provides a similar and more powerful functionality. So you could migrate your test using that. Or say you want to use other construct like complex numbers. There is a complex module that you could use. And for instance, in this Mandelbrot set example, you see that we can write the equation in simple terms, so it makes the code more readable. All this works on all platforms, including embedded Swift. if you want to go further, there is this talk from WWDC 2020. Now, you know that tool we talked at the beginning about the markup, the Markdown table of content? I keep thinking about it, and I think we should have a go at implementing it. And turns out that I have a Markdown file that's my upcoming bestseller about Apple history, so we can use that as an example. Now, you may think Markdown is easy, and just extracting heading would be a simple grep or something. But if you look at the spec, it turns out it's a bit more complex than that. So this would be the typical way I would write a header. But you can have as many spaces between the hash and the text, and that's still correct, and the spaces are not part of the text. You can repeat the hash after the header. You can have up to 3 spaces in front of the hash. You can use something completely different called the setExt heading with 1 underlining character, or as many as you like. And also, Xcode seems to think it's a heading. The spec mandates a space between the hash and the heading. Having more than 6 hashes is not allowed. It's not heading, it's paragraph. Having more than 3 spaces, it's not allowed, it's a paragraph. Escaping the hash, it's not allowed, it's a paragraph. Oh, you got the gist. It's not that simple, and so using a proper Markdown parser seems like a good idea. And the Swift Markdown package provides that. So again, we add the dependency, and we can now import the module and parse the document, either from a string or from a URL, as we are doing here. And so just to get an idea of what this gives us, let's print the debug description. What this gives us is a tree of markup elements with a document at the top. But be mindful, the structure represents the hierarchy of the document, not a semantical relationship. And so the document contains a heading element, which has a text element, which is really the text of the heading. But the heading level 2 is just another child of document. It's not a child of heading level 1. Okay, so once we have the tree of markup elements, there are methods or functions to search through the tree, etc. But usually what you want to do is walk through the whole tree. And there is a pattern to do that. It's the visitor pattern, which the framework or the package provides. And so the visitor pattern typically allows you to separate the algorithm used to traverse the data structure from the logic that you apply to each node. And the package provides 3, in fact. It has a generic version where the visit method returns basically any type you want. And that is very useful if you want to convert, for instance, from Markdown to XML. There is another version that returns an optional markup, and that's used to edit the tree. So you could return an edited markup, or you could return nil, and that would remove the node from the tree. There's a third version which returns void, and that's where you visit the whole tree, but you build your output in a different way. And that's what we can use, which will collect the heading nodes into a list. So let's implement that. We create a headers collector structure conforming to the markup worker protocol. We instantiate one, ask it to visit the whole document. Of course, for now, it doesn't do anything. We then implement the visit heading method that would be called for each heading, and it just collects all the markup inside of a simple list. Once we are done, we can construct a document object that is just using all the headings that we've collected, and we can use that to produce an output, formatting it with our different options in the package. And we can see that we had the full table of contents. Taking the depth flag into account is quite easy. We just pass it to our collector, and then before we add the heading, we just check its level, and of course add it or not based on that. And so this works fine, just giving us the 3 first levels of heading, which was the default that we used when we implemented the argument parsing. The skip empty section functionality is a bit more involved, and I will not go into all the details. Again, I will publish the source code of the sample. But I want to point out one thing. There's a default visit function that you can implement. And if you implement that and do nothing, what happens is that it's called for all the nodes for which there is no explicit visit method, including document. And so as we start visiting the document, the first thing we do is nothing, and so the program does nothing. And so you must implement then a specific version of the specific method to visit the document and tell it to visit all its children. Otherwise, nothing happens. Okay, one more package. Well, maybe two. Okay, 3 and that's it, I stop. So, in a past life, I've worked on a digital identity solution. It was backend, it was Java, but of course, security was important and we were working with quite a few certificates. And so I wanted to check what was the state of handling certificate in Swift. And on the Apple platform, it's been there since the beginning, the very beginning, I mean macOS 10.0. And it hasn't changed that much. And it's using Core Foundation. And for all the youngsters in the room, Core Foundation is ancient. So there is the Swift certificate package. It's quite interesting because it provides a more modern take on using certificate, but it also integrates with the existing object like Swift SEC certificate. So it's a nice continuity thing. And when I was preparing the presentation, I was looking at an example and what I could do and potentially use Swift certificate to do certificate pinning, and thinking that I would need to introduce a lot of concepts for all this to make sense, and ended up saying, well, that's a whole other talk. And it is a whole other talk, and we'll have the pleasure to tomorrow listen to Aline, who will talk to us about certificate and mutable TLS, so looking forward to that one. Embedded Swift is a topic I really like, so I wanted to mention that there are a few packages related to that. There is Swift MMIO, which is greatly simplifying your life if you're doing bare metal programming. And there is this, the Swift Embedded Examples repository that has a collection of examples that ranges for nearly all the platforms that Embedded Swift supports. Now let's go back to the desktop. I don't know if you've ever wanted to spawn an external process, for instance, running a non-Swift command line tool to process some data. Well, I did, and I use process for that. That's the current way of doing it. It's a bit old. It uses completion blocks and notifications. And in fact, if you look at the Objective-C documentation, it's the old NS task. Also, getting the IOs right is not straightforward. And so there is the subprocess package that makes it much more easy to spawn external processes, also connect the input-output, and that's available on macOS, again, Windows, and Linux. And to me, this is clearly also another sign of the direction that the platform is going in. It shows us the future of the standard platform. And this was confirmed, because if you look at the Swift 6.2 release post, it clearly introduces the subprocess package as a kind of a preview API to what's coming in the 1.0 version. Okay, that was quite a lot. Hopefully you're more lying in the middle emoji than the other ones. Let's see afterwards. So let's recap. I've presented quite a few packages, and I hope you discovered something that can be useful for your project. But besides that, what did we learn? Well, we've seen that some of those packages can show us a bit, it's crystal ball, it shows the future of the platform, where it's going, like we saw with subprocess. So I find it very interesting. Also, I haven't had a lot of chance to show that to you yet this time, but looking at the internals is quite useful. And if you read the source code for some of those packages, you can see how they use the language and the tool, and I find it sometimes it's easier to get information from looking at the source code than reading the documentation of some foundation feature or whatever. But it shouldn't stop there. You can go further and contribute. I have a few PRs that got merged that were just a few bytes long. Also, asking questions, reporting a bug is very much appreciated. And if you reported issues to Apple in the past with feedback assistance, well, it can be frustrating. It's a bit of shouting into the void. I had a very different feeling here. This one was approved the same day, merged 2 days later. So for me, it gives kind of a closer connection to Apple engineers, and it gives back a bit of humanity to Apple, which for me, I find lacking a bit these days. Okay. So there are, of course, many, many more projects that you can explore. Apple is adding, all weeks they have a new package. As Richard showed you, there was one last week. And so my hope with this talk is really that I give you hunger to go explore and see what's out there. Of course, I talked about the Apple packages, but there are so many other people contributing open source packages to the community. And the Swift package index is a great resource to discover that. Also, by the way, no documentation for all the Apple packages I showed are now hosted in the Swift package index. Swift on Server also has quite a few interesting packages on GitHub, and you'll certainly know more about that in the next presentation by Tim. Again, Q&A if you haven't had time. And with that, I want to thank all the contributors to all the open source projects that are published, by Apple or not. I want to thank Adam and the team for giving me the opportunity to talk today, and thank you for your attention.